Hello everybody, I am Abul Faz Bezatpour, and in this video I'm going to explain the chemistry and the chemical structure of cyanate and fulminate. As you know, carbon, nitrogen and oxygen are three adjacent elements that due to their electronic properties form many binary compounds with each other, and among which are carbon monoxide, cyanide anion, nitrosyl cation, carbon dioxide, nitrogen dioxide, nitrous oxide, carbonate, and nitrate anions. The ternary arrangement of these three elements can be as follows: CNO, OCN, and NOC. We know that the electronegativity of carbon is 2.55, nitrogen is 3.04, and oxygen is 3.44. And we know that oxygen should definitely not be the central atom. But why? Because oxygen is more electronegative than nitrogen and carbon. In fact, the central atom should not be the atom that has the most electronegativity, because it must share its electron with all surrounding atoms. So I have two important points for you. The most electropositive element is often placed as a central atom. And the second is usually if the electronegativity of two atoms are very close to each other, the atom with the larger radius is placed as the central atom. The reason is that the atoms with larger radius probably belong to the elements of the third and fourth periods of the periodic table and have suitable orbitals such as D, and if needed, they will have the possibility of establishing pi bonds with the surrounding atoms in order to gain more stability. You probably decided to ignore structure 3 altogether earlier than I did. Do you know what the two remaining structures are related to each other? Excellent. They are the structural isomers of each other. The structural isomer is another compound whose molecule has the same number of atoms of each element with distinct bonds between them. The name of first structure is cyanate, and the name of the second structure is fulminate. I will draw the loose structures of both and talk about their stability using formal charge. I want to count the valence shell electrons for OCN minus. Then I count 4 electrons for the carbon, 5 electrons for the nitrogen, and 6 electrons for the oxygen, and plus 1 electron because of 1 negative charge of anion, equal to 16 electrons. On the other hand, in order to consider the octet structure, we must consider 8 electrons for each atom. So for 3 atoms in the molecule, we will have 3 multiplied by 8 equals 24. The difference between the 24 and 16 indicates the total number of bonding electrons in the molecule. Then 24 minus 16 equal 8. That is divided by 2 to get the number of bonds in the molecule. So we will have 4 bonds for both structure. If we subtract the number of bonding electrons, here 8 electrons, from the valence shell electrons, here 16 electrons, the number of non-bonding electrons is obtained 8 electrons. That is divided by 2 to get the number of lone pairs on the molecule skeleton. So we will have 4 lone pairs for both structure. Now I want to draw the resonance structures of these 2 isomers with unprecedented speed, and I want to remember the 4 bonds for each resonance structure. Now it is the time to distribute the 4 lone pairs on the resonance structures. Make sure that the octet structure is followed. Isn't my speed amazing and unique? If so, then subscribe to my channel right now. Now I want to use the magic circles to get the quick formal charge. You can see my other video about the determination of formal charge in my channel. With the considering in the cyanate anion resonance structures, you quickly eliminate the C structure simply because the oxygen has positive formal charge. And between the structure A and B, the structure A is more stable because oxygen is more electronegative and has a negative formal charge. Of course, if I want to be more precise, the real structure is a hybrid of 2 structures, A and B. And in this hybrid resonance structure, the contribution of structure A is more than structure B. But let's continue our discussion about the structure of fulminate. Yeah, wow, what unstable resonance structures. None of these structures are stable because in all of them nitrogen, which is more electronegative than carbon, has a positive formal charge and carbon has a negative formal charge. This is not acceptable at all. However, among these 3 awful structures, we can choose only a structure A as the fulminate anion structure. Fulminate is ambidentate ligand. It means that depending on the reaction conditions and the kind of the metal, it can choose one of its sides to be coordinated. Of course, this ligand is very unstable and usually forms a solid compound in the presence of silver and mercury salts in the presence of nitric acid and ethanol. In the mercury fulminate, the fulminate prefers to be coordinated to the mercury cation through the carbon for 3 reasons. The first reason is due to the electron properties and electronegativity. Oxygen is more electronegative than carbon and will definitely give electrons to mercury harder than carbon. The second reason is based on Pearson's principle in hard and soft species. Carbon with a negative formal charge and mercury with 2 positive charges are soft species, and oxygen is a hard species. So, according to Pearson's principle, the interaction of carbon with mercury is more suitable than the interaction of mercury with oxygen. The third reason is based on orbital overlaps. According to the considerations of molecular orbital theory and the presence of pi bonding orbitals on carbon, the possibility of pi-back bonding interaction will be more on the carbon side. In case, even the few synthesized complexes of mercury and silver are very unstable. The weak nitrogen-oxygen single bond is the main cause of this instability. On the other hand, nitrogen with positive formal charge does not like the bond with its neighboring carbon with a negative formal charge. Therefore, nitrogen easily creates a stable triple bond with the nitrogen atom of the side molecule, and the result will be a strong explosion and the production of nitrogen and carbon monoxide gas along with a large amount of energy. Yeah, mercury fulminate is highly sensitive to heat, shock, and friction, making it suitable for initiating the detonation of other explosives. Still, its use has been limited due to the toxicity of mercury and the potential for the environmental contamination. In the Breaking Bad series, Walter White demands his dollars from Tuco by throwing mercury fulminate. Of course, the series was somehow attractive to chemists and maybe everyone. However, it was a bit exaggerated and had a lot of seasoning. For example, crystallization of mercury fulminates is not an easy task due to its unstable condition, and especially if the size and amount of the crystals are large, they definitely need a well-equipped laboratory. And it is very difficult to carry this amount of mercury fulminate, especially if you throw in the corner of the car and carry it. or if you hold it tightly in your hand and treating the tuco. But still, we really enjoyed seeing Walter White's chemical adventures in this series.